NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The James Webb Space Telescope has captured an image so shocking it could rewrite the rules of the universe. For decades, we thought we understood how galaxies and stars formed, but this discovery flips all of that upside down. Could this be the moment we realize everything we've been taught might be wrong? Let us uncover the image that confirms the actual evidence of alien life. The Big Bang Theory faces its biggest test. Astronomers have always placed their faith in theories and calculations built upon observations from earlier, less sophisticated technology. One of these foundational pieces was the cosmic microwave background radiation, CMB, discovered in the 1960s. This ancient light, thought to be a remnant of the Big Bang, was seen as a snapshot of the infant universe. From it, scientists gleaned information about the universe's expansion, density, and even its age. But as Webb's sharper eyes take their turn, it's becoming clear that we might have misread this so-called picture for decades. Before we delve into this, it's becoming clear that the truth behind the cosmic microwave background is far more unsettling than anyone dared to believe. And this revelation is only the beginning. Consider the Hubble constant, the measure of the universe's expansion rate. For years, scientists have been battling over conflicting values derived from different methods. One method, using the CMB, suggested a slower expansion rate. Another, relying on observations of supernovae, suggested a faster one. This discrepancy, called the Hubble tension, was already a red flag. But now Webb has revealed galaxies so old and well-formed that they shouldn't exist if the Big Bang timeline is accurate. These discoveries are turning that red flag into a flashing siren. Take, for example, Webb's findings of galaxies that seemingly predate the Big Bang itself. How could something exist before time supposedly began? This isn't just a minor inconsistency, it's a full-blown crisis. If these galaxies are as old as they appear, then the Big Bang Theory, the cornerstone of modern cosmology, might need to be replaced. Scientists are left scrambling, questioning whether we've misunderstood the CMB, the expansion of the universe, or even the nature of time itself. This isn't the first time that science has had to eat humble pie. Centuries ago, Newton's laws of motion and gravity seemed to explain everything, until Einstein came along and showed that space and time are more fluid than we thought. Einstein's theories, in turn, have hit their own limits. They can't fully explain the universe's behavior, especially when it comes to dark matter and dark energy, the strange substances that supposedly make up 95% of the cosmos. And here's the kicker. Webb's data is making these dark components look even more dubious. Dark matter and dark energy have never been directly observed. They were invented to patch holes in our models, much like a Band-Aid covers a wound. But what if these substances don't exist at all? Webb's findings suggest that the universe's behavior might be explained without them, by tweaking existing constants or embracing entirely new theories. For instance, some scientists are exploring the idea that gravity, the force that supposedly governs everything, might work differently on cosmic scales. If that's true, then our entire understanding of physics could be upended. Another area where Webb is shaking things up is with redshift, the phenomenon used to estimate the distance and age of celestial objects. For decades, redshift measurements have been treated as gospel. The further a galaxy's light is shifted towards the red end of the spectrum, the farther away and older it's assumed to be. But Webb's observations are challenging this assumption. Some galaxies appear far older and more massive than their redshift suggests, raising the possibility that our calculations have been wrong all along. Then there's the issue of cosmic structure. Webb has unveiled a vast cosmic web of galaxies and filaments that defies current models. These structures are far more organized and mature than they should be, given the supposed age of the universe. It's as if we've stumbled upon a fully built skyscraper in a city that's barely begun construction. How did these galaxies form so quickly? The answers aren't just elusive, they're fundamentally unsettling. The impact of these findings is rippling through the scientific community. For some researchers, Webb's discoveries are a call to arms, an opportunity to develop bold new theories. For others, they're a source of existential dread, as lifetimes of work are called into question. Imagine spending decades building a model of the universe, only to have a single telescope render it obsolete. That's the reality facing many astronomers today. Webb's discoveries are not just changing how we see space, but also making us think differently about life and our place in the universe. The universe is not what we expected, but this isn't just an academic problem, it's a philosophical one. If our models of the universe are so flawed, what does that say about our ability to understand reality? Are we merely scratching the surface of something far more complex and unknowable? These are the kinds of questions that Webb is forcing us to confront, and they're as thrilling as they are terrifying. Despite the chaos, one thing is clear. Webb is a game changer. Its ability to capture light from over 13 billion years ago is unparalleled, offering a glimpse into the universe's earliest moments. But with great power comes great responsibility, and Webb's findings are demanding a level of scientific humility that's rare in a field built on certainty. It's a reminder that science isn't about having all the answers. It's about asking the right questions. As more data pours in, the stakes couldn't be higher. Will Webb's discoveries lead to a new golden age of astronomy, or will they plunge the field into turmoil? Either way, one thing's for sure. The universe is far stranger than we ever imagined. And thanks to Webb, we're finally starting to see it for what it truly is. Not a neat, predictable system, but a vast, bewildering question that will keep us guessing for generations to come. Consider the material composition of these ancient galaxies. Webb's spectroscopic abilities have shown us chemical fingerprints that suggest elements like carbon and oxygen existed in these galaxies far earlier than anticipated. The presence of such complex elements points to an even earlier generation of stars that had to live, burn, and die, forming these elements before the observed galaxies could exist. This timeline completely contradicts the framework we have relied on for decades. Moreover, the question of where we've gone wrong isn't limited to timelines. Another realm under scrutiny is the fundamental nature of light itself. Scientists have long depended on light's properties to draw conclusions about distance, age, and motion. But Webb's data suggests there might be subtle, previously unnoticed shifts in how light behaves across vast cosmic distances. If our assumptions about light's behavior are incorrect, every measurement we've made using it, from the size of the universe to its age, may need to be reevaluated. Cosmologists are also revisiting the role of neutrinos, the ghostly particles that interact so weakly with matter, they can pass through entire planets without slowing down. Webb's data has hinted at neutrino effects in early galaxy formations, suggesting they might play a far greater role in cosmic evolution than previously thought. If confirmed, this would require a complete overhaul of existing models to account for their influence on the distribution of matter in the universe. Similarly, the discovery of high-energy phenomena in distant galaxies has raised questions about the processes fueling them. Some of these galaxies emit light at levels far exceeding what standard models predict. Could this be evidence of entirely new astrophysical processes? Or perhaps it points to flaws in how we understand star formation and black hole activity. These are no small questions, and answering them could reshape our view of cosmic history. At the heart of this upheaval is the realization that our scientific knowledge is always provisional. Theories once thought unshakable are now on the chopping block, and Webb's data serves as a humbling reminder that nature does not conform to human expectations. For the next generation of scientists, this is both a challenge and an opportunity. They will inherit a field in flux, brimming with questions, but also ripe with potential for groundbreaking discoveries. Ultimately, the James Webb Space Telescope is more than an instrument. It's a catalyst for change. By forcing us to confront uncomfortable truths about our models and assumptions, it's pushing science forward in ways we never anticipated. The universe, as revealed by Webb, is a place of endless wonder and complexity, a stark reminder that, in the grand scheme of things, we're still in the early days of understanding the cosmos. The path ahead will be challenging, but it's one we must embrace with open minds and a willingness to question everything. The Hubble Space Telescope, once the crown jewel of space exploration, paved the way for these discoveries. In 2012, Hubble's extreme deep field image gave humanity its deepest view of the universe, capturing light from over 5,000 galaxies as they appeared nearly 14 billion years ago. While breathtaking, Hubble's capabilities pale in comparison to Webb's. Webb's near-infrared technology allows it to see objects 100 times fainter and farther, offering an unprecedented glimpse into the universe's infancy. After looking deep into the past of galaxies, Webb is now searching for new worlds that might hold surprising answers. A closer look at galaxies older than time. One of Webb's early triumphs was its first deep-field image, unveiled in July 2022. This image showcased a galaxy cluster called SMACS 0723, located approximately 4.5 billion light-years away. What made this image extraordinary was its clarity and detail, revealing structures and objects Hubble couldn't detect. This clarity is partly due to a phenomenon known as gravitational lensing, where massive objects bend light, magnifying distant galaxies behind them. Through this lens, Webb uncovered ancient galaxies from a time when the universe was just a few hundred million years old. Beyond these ancient galaxies, Webb has turned its focus to exoplanets, worlds orbiting stars beyond our solar system. One such exoplanet, K2-18b, has sparked intense debate. Located about 120 light-years away in the Leo constellation, K2-18b is believed to be a Hycean planet, a hypothetical type of world covered entirely in water. Observations revealed the presence of methane, carbon dioxide, and possibly dimethyl sulfide, DMs, in its atmosphere. On Earth, DMs is produced by life forms, specifically by microorganisms in the oceans. If confirmed, this could be the most compelling evidence yet for extraterrestrial life. However, the DM's detection isn't without controversy. The signal was faint and appeared in a spectrum range overlapping with methane, making it difficult to confirm. Scientists are now analyzing additional data using Webb's mid-infrared instrument, MIRARI, which could provide a clearer answer. If DMs is definitively detected, it would mark a historic breakthrough in the search for life beyond Earth. Yet even if proven, the question remains: what kind of life could exist on a planet with such extreme conditions? K2-18b isn't the only exoplanet turning heads. Webb has also studied ultra-hot Neptunes, gas giants with surface temperatures exceeding 1,700 degrees Celsius. These worlds, located alarmingly close to their stars, challenge our understanding of planet formation. Traditional theories suggest such planets shouldn't survive their stars' intense radiation and gravitational forces. Webb's observations are helping scientists unravel these questions, offering new insights into planetary evolution. Closer to home, the telescope is revisiting objects in our solar system, like the strange dwarf planet 2007 or 10. Located in the Kuiper Belt, this distant world is rich in organic compounds and water ice. Its slow rotation and peculiar orbit have confused astronomers for years. Advanced instruments are now analyzing its surface and atmosphere, searching for clues about the early solar system's chemistry and conditions. Such studies could provide valuable context for understanding Earth's origins. The telescope's capabilities extend beyond planets and galaxies. It is also shedding light on rogue planets, worlds that drift through space without a parent star. These elusive objects, nearly invisible against the backdrop of space, emit faint thermal radiation that the telescope can detect. By studying rogue planets, scientists hope to uncover their origins and prevalence, adding another piece to the cosmic problem. One of the most exciting areas of the telescope's research is its ability to observe planetary systems in formation. The star Fomalhaut, surrounded by a dusty debris disk, has long intrigued astronomers. Detailed observations of this region revealed structures and gaps in the disk, possibly caused by forming planets. These findings provide a rare glimpse into the processes that shape planetary systems, including our own. While these discoveries have been celebrated, they've also stirred controversy. Observations of ancient galaxies suggest that some of them formed much earlier and were far more massive than current models predict. This challenges the Big Bang theory and the timeline of cosmic evolution. Scientists are now grappling with the implications, questioning whether our understanding of the universe's origins needs a complete overhaul. One of the lesser-known yet fascinating aspects of the telescope's work is its ability to study cosmic dust. These tiny particles, often overlooked, are essential building blocks of planets and stars. Its advanced infrared sensors can analyze the composition of these particles in unprecedented detail. For instance, studying the dust in regions like the Orion Nebula could provide insights into how stars like our Sun form and evolve. Additionally, this research helps scientists understand the chemical evolution of galaxies, shedding light on the processes that create complex organic molecules. Webb's work is now showing us how black holes grow and what distant moons might tell us about life in space. Star nurseries hidden in clouds. The telescope's ability to peer through dense clouds of gas and dust has also revealed previously hidden star-forming regions. These areas, often referred to as stellar nurseries, are where new stars are born. By observing these regions, scientists are understanding the factors that influence star formation, such as the presence of magnetic fields and the role of turbulence within the clouds. These findings not only deepen our understanding of the universe, but also have practical implications for understanding our own solar system's origins. Another groundbreaking aspect of its work is the study of black holes. While black holes themselves don't emit light, their intense gravitational pull can heat surrounding gas to extreme temperatures, causing it to emit radiation that the telescope can detect. Observations of supermassive black holes at the centers of distant galaxies have revealed intricate details about their structure and behavior. For instance, the telescope has provided new insights into how black holes grow and influence their host galaxies, challenging previous theories about their role in galactic evolution. Its exploration isn't limited to distant galaxies and exoplanets. It's also transforming our understanding of the solar system. Detailed observations of objects like Jupiter's moon Europa, which is believed to harbor a subsurface ocean beneath its icy crust, are providing critical data. By analyzing the moon's surface composition, scientists are determining whether conditions might be suitable for life. Similar studies are being conducted on Saturn's moon Enceladus, another prime candidate in the search for extraterrestrial life within our solar system. In addition to studying individual objects, the telescope is revolutionizing our understanding of cosmic phenomena like supernovae. These explosive events mark the end of a star's life and play a crucial role in enriching the universe with heavy elements. Its ability to observe supernovae in detail is providing new insights into the processes that create elements like gold and platinum. This research not only enhances our understanding of the universe's chemical evolution, but also has practical implications for fields like materials science and nuclear physics. The telescope's contributions to astronomy are not limited to its discoveries. It is also a technological marvel. Its primary mirror, made of 18 gold-coated segments, provides unprecedented sensitivity and resolution. This allows the detection of faint signals from the most distant objects in the universe. Additionally, its location at the second Lagrange point, nearly 1 million miles from Earth, ensures a stable and unobstructed view of the cosmos, free from atmospheric interference. The telescope's instruments are equally impressive. Its near-infrared camera, NIR-CAM, is capable of detecting light from the earliest galaxies, while the mid-infrared instrument, MIRI, provides detailed images of cooler objects like dust clouds and exoplanets. The Fine Guidance Sensor, FGS, ensures precise pointing, allowing it to focus on specific targets with unparalleled accuracy. Together, these instruments enable the study of a wide range of astronomical phenomena, from the birth of stars to the formation of planetary systems. Its mission is a testament to international collaboration, with contributions from NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. This partnership has not only made the telescope's development possible, but also ensures that its data is shared globally, fostering collaboration among scientists worldwide. The findings are accessible to researchers across disciplines, enabling breakthroughs in fields ranging from astrophysics to planetary science. As the telescope continues to operate, its discoveries are likely to become even more transformative. Upcoming observations include studying the atmospheres of Earth-like exoplanets, searching for signs of habitability, and exploring the nature of dark matter and dark energy. These efforts have the potential to answer some of the most profound questions about the universe, from its origins to its ultimate fate. The James Webb Space Telescope represents a monumental leap in our ability to explore the cosmos. Its findings are rewriting textbooks, sparking debates, and inspiring wonder. As new data continues to pour in, one thing is clear: our understanding of the universe will never be the same. The telescope's legacy will not only be measured by the knowledge it generates, but also by the new questions it inspires, ensuring that humanity's quest for understanding continues for generations to come. Could this image from the James Webb Telescope be the key to unlocking the universe? Or does it reveal something scientists are afraid to admit? Tell us your thoughts and remember to like and subscribe for more.